Question number 2 is integration by parts. Both part A and B are about integration by parts. In C3 we have seen that when you do a product rule in derivative, it has a special rule. When you cannot multiply two variables into simple format, you use the product rule or you use the quotient rule if it is divided. In case of integration, when you have two variables that cannot be simplified into further something in addition or subtraction format, we use integration by parts. X e to the power x is one of the most common integration by parts questions. So when you do this, this is how the whole thing works. You integrate u is one of the terms, and another term, it could be v, but it is more convenient if we write the other term as dv by dx instead of v, because if we write one term as u and the other term as v, the formula looks much more complicated. For simplicity, we use one term to be v and the other to be dv by dx. In derivative product rule, when we it doesn't really matter which one is u and which one is v, but here it's not that whatever is in front we call it u and the other one is v. That is not the case. There's a special rule, and we can say the preference of u is L A T E. L for logarithm, A for algebra, T for trigonometry, E for exponential function. That means exponential function has the least preference for u. So when you have this x and e to the power x, it is clear that algebra is x and exponential function is here. So the most preference goes to algebra, so u is going to be x. So if I start doing the sum, integration of x e to the power x, we can write for u equals to x, and we can write and dv by dx equals to e to the power x. Okay, now the rule. The by parts rule states that uv minus integration of v and derivative of u. That's it. That's integration by parts. Now we don't have v, we have dv by dx. If you remember from C1 how you solve a differential equation, it's integration. That's the fundamental rule of calculus. Integration is the opposite of differentiation. That means if you want to find v, it would nothing be but the integration of e to the power x. Integration of e to the power x is simply e to the power x, and we have the chain rule divided by the derivative of the algebra, but since it is x, we don't have to write divided by 1. Now here we don't have to write plus c, although this is an indefinite integral, because we write it at the end of the sum and we are still in the middle. Another thing that we need in the by parts formula is the derivative of u. So the derivative of u is du by dx. This is 1. Let's start. Hence, integration of x e to the power x dx equals to u v minus integration of v du by dx, which is 1. So write down the answer, x e to the power x minus integration of e to the power x. Since into 1 means e to the power x is e to the power x. The sum is done. Indefinite integral, we can write plus c. So this is the first question. Now the next question is x squared e to the power x. It only means that we have to do the sum twice. That's all. So question number B, integration of x squared e to the power x dx. We can write for u equals to x squared. Remember again, by the preference LATE, algebra gets more preference than exponential function, and the rest is dv by dx, which is e to the power x. Now we need v in the formula, so we write v is nothing but the integration of e to the power x, which is e to the power x, and we also need the derivative, which is du by dx equals to 2x. Hence, integration of x squared e to the power x dx is equals to u v minus integration of v du by dx dx. We can write this as x squared e to the power x minus, now we can bring the constant outside and rearrange it, like write it as x e to the power x dx. Now we have already written this out in the previous sum. So x e to the power x is integration is x e to the power x minus e to the power x plus c. So all we have to do is plug it in, that's all. So we can write x squared e to the power x minus 2 x e to the power x minus e to the power x, and at the end, since this is another sum, we just have to write 1 plus c. That's all. So that's all we have to do. We can put x e to the power x minus e to the power x, and the constant is at the end. So the answer would be x squared e to the power x minus twice x e to the power x minus plus 2 e to the power x plus c. So that's it. So this is the sum. So you have this x e to the power x minus e to the power x. This is correct. And question number B is x squared e to the power x minus 2. This is also correct. So the report says that in part A, many candidates were able to use integration by parts in the right direction to produce a correct solution. Common errors included integrating e to the power x incorrectly to give ln x. This is a common mistake. Or applying by parts formula in the wrong direction by assigning u as e to the power x. It is important to give the preference of u to algebra, LATE, remember that. And many candidates were able to make a good start to part B by assigning u as x squared. So they were able to do this, but the problem is when they faced this again, they did not make any connection to question number A. So you have to remember to take the help of the previous sum. So that's important. Now let's take a look at the exam structure of integration. We have integration by fundamental rule and trigonometric identities. What we just did was integration by parts. Now we have questions of by substitution, by breaking it into partial fraction. Partial fraction is simple algebra, which was in C1, C2. So simple algebra. And there is also by solving differential equation, separable method. Solving differential equation is a concept. You just separate the expression, but what you basically have to do, the integration, is by fundamental rule. So you can say by fundamental rule is the basic integration, and by substitution or by parts or by solving differential equation or by partial fraction, these are preparing or simplifying the variables to be integrated. But the actual integration, when you do the integration, is by the fundamental rule. Fundamental rule of calculus states that integration is the opposite of differentiation. When you did by parts, it's just one line. But the rest, the integration of e to the power x, and that came from the fundamental rule of calculus. The derivative of e to the power x is e to the power x, so the integration of e to the power x is also e to the power x. Then by partial fraction is basically you break down an algebra fraction expression into fraction, partial fraction. And this is the opposite of what you do in C3. C3, they give you some fractions in algebra and you simplify them into the simplest form. Here they give you the simplest form and you break it down into other fraction, and then you do the integration. So that is the structure of the integration sum. So the first, we have to express it as a partial fraction. The idea behind partial fraction is to break it down into linear factors. So 4 is 2 squared. So 2 squared minus y squared can be written as 2 plus y, 2 minus y. It's like a squared minus b squared is a plus b, a minus b. So this is a constant divided by one of the factor plus a constant divided by another of the factor. So when we take the LCM has to be the same as the previous one. So you don't have to figure it out, just copy the LCM from here. So this and this is same, so a into 2 minus y plus this and this is same, b into 2 plus y. So we can write this, since the upstairs this and this are equal and this cancels off. So we don't have to worry about what's downstairs, we have to equate these two upstairs. So 2 equals to a plus 2 minus y plus b plus 2 plus y. Now remember what we're doing. We are taking a simplest form of a fraction and we are breaking it down into two fractions. So partial fraction, so that we add this up and we get this. In order to do that, we have to take two factors. So one of the factor is 2 plus y. So if 2 plus y is 0, then one value of y would be minus 2, and if 2 minus y is 0, the value of y would be 2. So we can find the value like that. So for y equals to 2, 2 equals to, if I put 2 here, it becomes 0. So 2 minus 2 is 0. Plus if I put 2 here, it becomes 2 plus 2, 4b. That makes it b equals to 2 by 4, which is half. Then if I put for y equals to minus 2, I can write 2 equals to, since there is no y here, this 2 would be 2. So I can put here 2 minus minus 2 is 4. So 4a plus 2 minus 2 is 0. Therefore, a equals to half. So that makes the partial fraction to be answer. So 2 by 4 minus y squared can be written as 1 by 2 plus y plus 1 by 2 minus y. So 2 plus y, this is half we can write it as 1 by 2, and this is the partial fraction. Now the next question is the integration. This is, you have to solve this differential equation. Any equation that has dy by dx, it means you have to solve it. To solve a differential equation means you have to integrate it. All you have to do is separate them, separate the expression. So the expression is like this: 2 cot x dy by dx equals to 4 minus y squared. You have to take the help of the previous sum. Besides, they have said hence obtain the solution. So the previous sum, so it was, so let me write it down first, like separate it. So the 2 is here, the dy is here. I'm sending the y expression with the y. So 4 minus y squared equals to, now this would be 1 by cot x, and this is dx. So that's how you separate the expressions. Remember, usually the constant, it's a good idea to send the constant on the right hand side with x. But here, since in the original question we have 2 by 4 minus y squared partial fraction, so you might expect this in the next question. So you have to remember this. You're going to use this partial fraction for the next question. So this is a common way of asking the question. So let me write this as a partial fraction. So that would be 1 by 2 plus y, plus 1 by 2 minus y, breaking it down into the partial fraction dy. And reciprocal of cot x is tan x dx. Let's do the integration. I have written out here derivative is from the fundamental rule of calculus. The derivative of ln x is the reciprocal of x. So the integration of the reciprocal of x is ln x, by the fundamental rule which says integration is the opposite of differentiation. And remember, if you have a reciprocal of a linear expression, it has to be a linear expression because originally it is coming from the derivative. It is going to be ln of that, but remember the chain rule here, it is divided by the algebraic expression. That's a common mistake. So half is half, it's a constant. So ln of 2 plus y is going to be the integral, and remember the chain rule, derivative of this is 0, this is 1. It's a good idea to write this. So half, this is going to be ln of 2 minus y divided by, now look here, the derivative of this is going to be minus 1. You have to remember this, equals, now this one, integration of tan x. This is not something that you'll find in the fundamental rule of calculus straightforward. It will be given in the exam formula booklet that is provided. So this is the formula booklet that will be provided in the exam, and in the C4 page we'll find that the integration of tan x is given. It is logarithm ln of sec x. So that's the integration. So we can write ln of sec x plus c. Now it's a good idea to give the absolute value sign, the modulus sign, because we know that logarithm cannot be of a negative number. So it's a safety barrier. In case if it is negative, you have to turn it into positive. That's all. So we can write this, we can take the half common, and we can write ln of 2 plus y minus, this minus comes here, ln of 2 minus y equals to ln of sec x plus c. So we can simplify this and write ln of, this is from C2, logarithm a minus logarithm b is division. So this is ln of 2 plus y divided by 2 minus y, so equals to ln of sec x plus c. So this is more or less like a C1 solving a differential equation where you have to find a constant, because this is a general solution. Whenever you have a plus c or a constant, it's a general solution. So the value of given y equals to 0 and x equals to pi by 3. So let's use that value. So when y equals to 0 and x equals to pi by 3, so half ln, so 2 plus 0 is 2 divided by 2 minus 0 is 2, 2 by 2 is 1, equals to, so ln of, we can write sec x as reciprocal of cos x. We can write 1 by cos of pi by 3 plus c. Now if you take a look here, from a review of C2, you remember pi by 3 in radian mode means degree is 60 degree, because we understand a degree better. So sec 60 degree means 1 by cos 60 degree. Now if you remember this from C2, it's half of an equilateral triangle. This is side 2, this is side 1, and by Pythagorean theorem we can get square root of 3. So if this is 60 degrees, so adjacent by hypotenuse is going to be 1 by 2. So cos pi by 3 means half. So we can write it as, since ln 1 is 0, this is 0. This is ln of 1 by half plus c. So 0 equals to ln, reciprocal of half is 2. Therefore c equals to minus ln 2. So that is the value of c, and we can write hence this is half ln of 2 plus y by 2 minus y equals to ln of sec x minus ln 2. So that is the expression. Now we have to further simplify this. So the question was, your answer has to be written in such a way it is sec squared x into some sort of an expression of y. So let's try to do this. So we have to simplify this. So let's do this. So let's bring all the logarithm on one side and keep this logarithm of sec on this side. So half ln of 2 plus y, 2 minus y plus ln 2 equals to ln of sec x. So we can write this as, the half can come here and it can become a square root. So it can become 2 plus y, 2 minus y to the power half plus ln 2 equals to ln sec x. Remember this from C2 rule. If you have a ln b, you can write ln b to the power a. This coefficient becomes the exponent. Now the addition rule. Since you have this added, you can write ln of this 2 into 2 plus y, 2 minus y to the power half. So when you have addition ln a plus ln b, you can write it as a product ln a into b. Okay, we have ln sec x. Now there's another rule. When you have ln a equals to ln b, you can simply write a equals to b. So that's a rule. So we can write, therefore 2 plus x by 2 plus y divided by 2 minus y to the power y equals to sec x. Now by the order of operation, we cannot send this to the other side unless this is free. So if I send the 2 to the other side, I can write it as 2 plus y divided by 2 minus y to the power half equals to sec x by 2. That means if I send now this half to the other side, it would be 2 plus y, 2 minus y equals to sec x by 2 whole squared equals to 2 plus y, 2 minus y equals to sec squared x by 4. Now the expression is, we have to write it as sec squared x equal to some sort of an expression for y. We can multiply this with 4 into 2 plus y divided by 2 minus y equals to x squared, sec squared of x. That's the expression. So this is the mark scheme. So this is the value of a and b's half and half, and this is the partial fraction. So this is correct. And the next one, there are many ways of showing it. They show alternate ways. And question number B, the first thing is to do the separable method. You separate the variables. You have to notice the previous sum. That's why they mentioned the hence. And you find the value of c is minus ln2, and the expression is 4 into this. That's what we got. So that's correct. So examiner's report says that in part A, many candidates realized that they needed to factorize the denominator to give two linear factors, and usually proceeded to give a fully correct solution. A few candidates, that means very few, that 4 minus y squared was an example of a repeated linear factor. They got mixed up with 4 plus y whole squared. That's a common mistake. It's not clear what they mean by a few candidates, significant minority. That's their way of saying perhaps a lot of people for a few. So significant minority of candidates who completed part A correctly made no attempt at part B. So there are quite a number of people who did not even try part B. So this must be a concern for them. This paper must be, this particular question must be a concern for them. So it says here, of all the 8 questions, this was the most demanding in terms of the need for accuracy. Fewer than 10% were able to score full marks. That means they had the problem in the simplifying portion where you have to convert a sec square x equals to something. That was a question, that was the problem they faced. So apart from that, this was all right. It was pleasing that candidates who progressed far were able to correctly integrate tan x and correctly find the two ln terms by integrating their partial fraction. Common errors at this point were integrating tan x to give sec square x. Note that the derivative of tan x is sec square x. The integral of tan x is ln of sec square x. So remember, so I guess this is one of the most demanding question in terms of simplifying your answer into the given format. That is important. The final question is a parametric equation. A parametric equation is Cartesian equation expressed in two parts in terms of a third variable called the parameter. We have this sketch, and we have the parametric equation of this curve C. So this would usually be in terms of a Cartesian equation x and y, but they have broken it down into two parts, and they're calling it a parametric equation. Now there would be one parametric equation exam question given, and there are concepts of both C1 and C2. Remember, you need to identify the question in terms of C1 and C2. So this parametric equation, the C1 concept that we have to find is find the equation of tangent on normal, find the point of intersection. These are the C1 concept. C2 concept is find the maximum Newton turning point or find the area or volume. So a question of parametric equation is coming from C1 and C2. So it's a Cartesian broken down into two parts. So that's, you can view it like that. So we have this equation and we have to find the value of t. Remember, the parameter is t. So here the Cartesian point is given. So we can either use this coordinate or we can use this coordinate to find the value of t. So this is easier. Use the simplest version. So this is the simplest version. So let me use when x equals to 4. So that means I can write question number A. When x equals to 4, I can write it as 8 cos t equals to 4. So cos t equals to 4 by 8, which is half. Now you don't have to, since it's just the value of t, you don't have to do the arbitrary angle definition with quadrant basic angle. You just do it simply. T equals to cos inverse or arc cos of half, and we know cos inverse of half is going to be 60 degree, and 60 degree in radian is pi by 6. So the value of t is going to be pi by 6. 60 degrees pi by 3. Let me correct this, pi by 3. So the next question. So the next question that we have, the line L is perpendicular or normal to the curve at the point P. So we have this curve and this is perpendicular. So this is a concept from C1. So in order to find, the next question is the gradient. In order to find the equation of a line which is perpendicular, you have to know the point through which it passes, the Cartesian point through which it passes. We have to go back and forth between Cartesian and parametric. So this is the Cartesian point, and we need a gradient. If you know the gradient and if you know the point, then you can find, this is the rule from C1, the equation of any line. So let's find the gradient first. So the gradient dy by dx here, since it is broken down into two parts, is going to be dy by dt divided by dx by dt, dx by dt. So let me break it down. For x equals to 8 cos t, the derivative dx by dt, this is from C3, you know the derivative of cos t is minus sin t, so minus 8 sin t. For y equals to 4 sin 2t, this is also from C3, the derivative of sin theta is cos theta, so cos 2t, and the chain rule, remember there's always a chain rule, so into in case of derivative, so 2t derivative is going to be 2, so this is going to be 4 to the 8 cos 2t. So therefore dy by dx equals to dy by dt, which is 8 cos 2t divided by dx by dt, which is minus 8 sin t. So this 8 and this 8 cancels, so we can write minus cos 2t divided by sin t. Now remember, this is in terms of t, and we know the value of t for the point P. So we know at P, the parameter t equals to pi by 3. Therefore, dy by dx. Now you need the concept of C2 trigonometry. So minus cos 2 into pi by 3 divided by sine pi by 3. So this value is going to be cos 2 into sine pi by 3, 2 into 120 degree, pi by 3 is 60 degree into 2, 120 degree. So we can just use this. This is the degree mode. We can convert it into radian into degree, and we can do this very easily. So cos 120 degree is minus half. So we can get this as minus of minus half. So minus of minus half. And sine 60 degree, sine 60 degree from that is going to be opposite by hypotenuse, root 3 by 2. You should have this memorized from C2. So if we simplify this, the gradient is going to be 1 by square root of 3. So that is the gradient. Now if this is the gradient, remember from the C1 rule, if this is the gradient of the curve, the gradient of the normal must be the negative reciprocal. So minus 1 by square root of 3 is minus square root of 3. So that is going to be the gradient of the normal from C1 rule. Now equation of the normal, so equation of line. Remember this is the rule, y minus y coordinate. The y coordinate is given, which is 2 square root of 3 equals to gradient. Then x minus x coordinate is given to be 4. So now we have to show this by rearranging. So this is going to be y minus 2 square root of 3 equals to minus x square root of 3 minus plus 4 square root of 3. We can write y equals to minus x square root of 3 plus 4 square root of 3 plus 2 square root of 3. So therefore we can just write minus x square root of 3 plus, if I take square root of 3 common, it would be 6 square root of 3. So that's it. So this was a 6-mark question. The next question, the finite region is enclosed by the curve C, the x-axis, and the line x equals to 4. Show that the area of the region. Okay, so this is a C2 question, area of the shaded region. So when you have the area of the shaded region like this, it means this is type 1, where you have just this region and the limit is from 0 to 1. That's it. So if you integrate, so this is the rule for C2 rule. If you integrate from this limit 0 to 4, remember area is always found by the Cartesian equation. You substitute it later on, but it starts with the Cartesian formats. If you integrate this y dx, 0 to 4 y dx, that is going to give you this region. So in order to do this question, you have to convert this into the parametric format. That means they told you to show an expression, so that means it has to be dt something. The limit is going to be in terms of t, so it's going to be substitution, because originally this is what it looks like. So if you have to do substitution, that means the substitution would be, so the limits would start with a value of t, and this would be another value of t. This expression would be some sort of a function of t, and dx would have to be some sort of a dt. So that's what you have to do, and this is called substitution. So this is the substitution sum. Remember, we can expect by part sum, substitution sum, partial fraction sum. These are the integration sum, and integration by separable method for solving differential equations. So this is something we were expecting. So let's do this. This is question number C. Okay. So question number C. So we know that shaded area in the Cartesian format is going to be 0 to 4 y dx. Now our main job would be to convert this into the form they have asked for. So let's start with the limit. So when x equals to 0, so we can directly write 8 cos t equals to 0, since x equals to 8 cos t. So therefore cos t equals to 0, and we can write this from memory. Cos t is 0 when it is 90 degree, or when it is 270 degree, but we can write only the first one. That is fine. You have to remember the C2 rules of trigonometry for this. When x equals to 4, we have already found it out. It is pi by 3, so we don't have to worry about this. This is done in part A. Now we need an expression for dx. So for x equals to 8 cos t, we also have the derivative from part B for the gradient. So dx by dt is going to be minus 8 sine t. So we need an expression for dx. So dx is going to be minus 8 sine t dt. So that's it. So now all we have to do is substitute. Hence, area equals to, so when we have 0, we have pi by 2. So we put the pi by 2 here. When we have 4, we have pi by 3. We put the pi by 3 here. When we have y, it is given in the parametric equation. Y is 4 sine 2t. So 4 sine 2t we put here in terms of y. And dx is minus 8 sine t dt. So that's it. Now there is a cool trick that you have to use. It's if you have a negative term in substitution, by flipping the limit, because the limit gives you which expression to subtract from what expression. By flipping the limit, this becomes positive. So that's what you have to do. So this could be pi by 3, and this goes here pi by 2. So by flipping it, we can write it as 4 sine 2t 8 sine t. So that's a cool trick. So now we simplify this. So pi by 3, pi by 2, so 8 4s are 32. Sine 2t can be broken. This is a rule from C3, double angle half angle rule. So sine 2t is 2 sine t cos t, and sine t is here dt. So we can write it down as pi by 3, pi by 2, 32 into 2 is 64. Sine t into sine t is sine squared t, and cos t dt. So I guess that's what we had to show. That's the expression that we had to show, and that's the expression. So now the next question is use this integration to find the area. So, and the answer has to be in this format, a plus b square root of 3. So that's what we have to do. Now this is a very common question. You have to remember this rule. One of the most common question at the end of parametric equation area or volume is something that looks like this. Sine to the power n theta cos theta d theta, or cos to the power n theta sine theta d theta. So this is one of the most common question, and whenever you have this, the answer is going to be sine to the power n plus 1 theta divided by n plus 1. That's it. So that means if you have sine squared theta cos theta, the answer would be sine cube theta by 3 minus cos to the power n plus 1 theta divided by n plus 1. This time it is going to be minus here. So remember, for cos it is going to be negative. So this is a short trick, but if you want to know how to do this in the long run, it's in the long way, you have to consider whatever has the exponent here as u. You have to do substitution. So if you have sine square theta cos theta, when you have this format, consider sine theta as u. Whatever has the power here, consider that to be u. So that's a common way of doing the sum, or you can memorize the trick. Substitution. So we consider whenever you have this format, integration of sine suppose square t cos t dt, the integration is going to be sine cube t by 3. That's it, plus c. But it's better to do it in the long way, and when you do it in the long way, you consider whatever has the power to be u, and you do the substitution just the way you did before. So you can either do it very quickly, or you can do it in this long version. So let me do it in the long version. So let u equals to sine t. I'm going to convert this into sine t. So the limit is going to be, when you have t equals to pi by 3, u is going to be sine of pi by 3, and sine of pi by 3 means sine of 60 degree is going to be square root of 3 by 2. So that is going to be the value, square root of 3 by 2. When t equals to pi by 2, u equals to sine pi by 2, which means 90 degree. Sine 90 degree is 1. So u is going to be 1 here. So we got the limits. For u equals to sine t, we need now the derivative. Du by dt is going to be cos t. So therefore, du equals to cos t dt, which matches here. Cos t dt is du. Hence, let's do the substitution now. So the substitution is going to be pi by 3 is going to be square root of 3 by 2, and this is going to be 1. And 64 is going to be 64. Sine square is going to be u squared, and cos t dt is going to be du. That means when we do this, the integration is going to be 64 u cubed by 3. Notice that if u is sine t, then u cubed by 3 means sine cube t by 3. So the limit is square root of 3 by 2 to 1, and we can simplify this. So we can write 64 by 3 1 cubed minus 64 by 3 square root of 3 by 2 whole cubed. Now the answer has to be in the format such that it is some constant plus another constant square root of 3. So we can write it as 64 by 3, this is the first constant, minus, of course they said plus, but plus or minus is the same thing, treat it here. So this is going to be 64 by 3 into, now square root of 3 whole cube means square root of 3 multiplied by square root of 3 multiplied by square root of 3. Now 2 whole cube means 8, 2 into 2 into 2 is 8. We can cancel this off, this 8 and this cancels and it becomes 8. So we can write 64 by 3 minus 8 by 3 into, now square root of 3 into square root of 3 is 3 and square root of 3 is left over. This 3 and this 3 cancels. So answer is 64 by 3 minus 8 square root of 3, the format they asked for. So the mark scheme shows that the first value is t equals to pi by 3. That's correct. Then question number B, we found the gradient. The gradient is 1 by square root of 3. For normal is the negative reciprocal is minus square root of 3. Since we were able to show this expression, so that's all right. So question number C, we started with the Cartesian format and we changed. That was also something we have to show. So we know that is correct. And finally, this question where the answer has to be in a particular format, we use substitution and we finally found the value to be 64 by 3 minus 8 square root of 3. This is also correct. So this is the examiner's report. In part A, many candidates were able to give t equals to pi by 3. Some candidates gave their answer only in degrees. This is important. In C3, C4, it has to be in the pi format. That is the convention. So if you give the answer in degree, you can think in degrees. That is fine because you're used to it at first. But you have to write down in radian format. So other candidates substituted the value of y of p and it became a bit complicated. The majority of these candidates did not go on to reject t equals to pi by 6. You have to use the first value, the smallest value. Remember that. In part B, many candidates were able to apply the correct formula for dy by dx, the chain rule, dy by dt divided by dx by dt, although some candidates mistakenly believed that differentiation of 4 sine 2t gave either minus. So remember, the derivative of sine theta is cos theta. The derivative of cos theta is minus sine theta. That's a very common mistake. Some candidates who had differentiated incorrectly substituted their value of t into this and they just tried to, get that answer somehow. It doesn't really matter whether the answer is right or not. If the method is wrong, you don't get the point. This is very, very important. Now, majority of the candidates understood the relationship between gradient and of the tangent and its normal, and many were able to produce a fully correct solution to this part. Remember, this is from C1. Now, a few candidates, however, did not realize that parametric differentiation required to convert the parametric equation. You don't have to do this. You don't have to do this converting the parametric equation to Cartesian. You can do this by using the chain rule, dy by dt divided by dx by dt. So you have to remember that is much easier. Few convincing proofs were seen in part C. Uh, Remember, when you shift this, it becomes positive. When you shift this can be shifted. Remember that part. Part D was unstructured in the sense that the question did not tell the candidates how to integrate. So in that case, usually they mention it using by parts, using substitution, using when you do partial fraction, they mention it all the time, which part you have to do. But remember this, in parametric equation at the end, it's a question that will always be something in the format of sine to the power n theta cos theta or cos to the power n theta sine theta, and you can either do it directly or you can do it using the limit. So using u equals to the one that has the power. So that is the idea. So overall, it is possible, however, to use a loop method, but this was very rarely seen. It was clear to examiners that a significant number of stronger candidates spent much time trying to unsuccessfully. That means stronger candidates means people who can do the other sums correctly. So they spend a lot of time. So you have to remember, it doesn't carry that much mark. So it carries 4 marks. In order to do that, you should do everything else, and whatever time you have left, put it here. So that's one of the reason many people cannot finish the exam on time, because a lot of time is wasted on other sums.